Nisha, hi Deepti. Tell me one thing. Whenever I create a class, right, I will click on notify. So you guys will get any notification whenever, like, when class is created.
No, sir. If you add anything in the folder, that time I'll get the notification.
Okay,
Yeah. Regarding the class, no, I'll not get the notification.
okay, okay. Let's wait for the class. Others also to join. What else? Are you guys started practicing this Python and SQL?
Yes, sir.
Okay, how is it going? Is it good? Like, are you facing any challenges or learning any new things?
No, as of now, it's going good. While writing some
Hmm.
queries, it
Hmm.
will getting wrong initially. Later, it was.
Okay, okay. Python and SQL are very important actually. So
Yeah.
someone needs to get into data engineering, right? SQL followed by Python, PySpark, and one cloud. It could be anything. AWS, Azure, or GCP. It's your choice. The AWS is user friendly. Azure is also good, but GCP is bit not user friendly. But GCP is also slowly coming into the market. But AWS and Azure are very much high in the market. So one cloud is fine, and SQL, Python, PySpark. Those are the most important things. Okay. So if you could learn them right, then
Mm.
that's it. You will be able to crack this email. And you all are freshers, right? Do you have any
Yes.
freshers? Okay, okay. So then you need to be very good because you never know when will the opportunity will knock your door. So you need to be ready. So you need to do that.
Yes.
Let's wait for the other people to join. And how are the classes, right? So are you able to understand? Are you able to cope up? Because sometimes I go fast, sometimes I go slow. If I feel that concept needs that time, I will give that time because within 1 hour, right? Sometimes, sometimes I will give that time to that concept. Spark, right? Spark, I will go in very slow pace, very very slow pace, dead slow, because Spark is very important. In your interview, you are going to get more questions on that. That's why I'm trying to come up with different examples as well. So whenever you feel any doubt or any difficulty, okay, just at least if you're unable to speak in the class, right, just try to ping me. Okay, this is the issue we are facing. Bit fast, bit slow, not understand, something like that. Some comments, some feedback, so that next class you'll get more, much more better things, right? So try to give feedback whenever you feel like. Okay,
Okay, sir.
fine. And how was Spark going, by the way? Are you able to understand what is PySpark? What is PySpark? How things are happening in PySpark under the hood? Under the hood, you read to know. I'm pretty sure because it's very difficult because the clusters and all, right? It's very difficult. Once you start working in the real time, like once you start doing hands-on or something, then you'll get to know more things. I'll try to set up those classes as well. So once this is done, right, I'll try to show a small demo on how we get the data from read small data, very small data, and try to do transformations on top of that. Take like say employee table and try to see uh, how we are going to do transformations on top of that. Transformation means like some processing we will do on top of that data. Okay, then we will create a few results, and then we will put that into some storage location. We will do that concept, the small things. But before that, you need to be very good at this theoretical part in the PySpark. So that's why the classes will be lengthy and it will be boring as well, because sometimes if you're lost in the middle, right, then you won't understand the next concept. So that's why if you're lost in the middle, then just ask in the group. Okay. Hi Veda, thanks for joining. Karthik and Arun need to join. Okay, let me ping in the group. Haven't joined. Copy. Hmm. Seems Karthik not responding. Okay, that's okay. Let him join. Anyway, we'll have the recording, right? Okay. So let's start. Let's start the class. Okay. Fine. You guys able to see my screen, right? Okay. Till here we covered yesterday, right? Till data partitioning. Okay. Let's go little bit further. What is RDD? Like you already know, right? What is the benefit of this Spark, right? Spark is very fast because it does in-memory processing. What is in-memory processing? In-memory processing means the Spark will read the data from the source. Source means some external system or something. Let's say this computer only. It will read data from the source and take the data and put it into RAM. Okay, RAM, and then it will start processing on top of that. Right? Spark will do that in-memory processing. That's why the Spark is very fast, 100 times fast compared to this MapReduce. That's what we discussed, right? Because MapReduce will do ROM processing, means it will keep the data as it is in the hard disk. So then it will process then and there. So that's why it's bit slow, no, very slow compared to Spark. Okay. Um, Now, if you come and see what is Spark ecosystem, you see right Spark core engine. See Spark. This is the storage. Storage can be anything. Hadoop, HDFS, S3, MySQL, all these things. Management, right? This is cluster management. You already know YARN. YARN means resource management. So resource management means cluster only. We call multiple resources work together to form a cluster. Right? Uh, YARN. So Mesos is also one of the YARN resource management cluster management available, and Spark itself will provide some standalone cluster, some cluster manager. Okay, and here the Spark core is the engine here. So you with the Spark you can interact with these many yarns. I mean these many cluster management tools, these many storages. There are many. We couldn't put all together into here, so that's why it's very less. Okay, and all these libraries, okay, and all these programming languages, okay, R languages, Python, SQL, Java, okay, but do not opt for Java. Okay, we only prefer Python. Okay, why? Because Python is very easy and it's user friendly. Okay, so that's why we always go with Python. And these are the abilities, Spark SQL. Instead of writing your code into Python, PySpark, okay, so you can just create some SQL. You can do some SQL like coding as well in PySpark. Okay, so that's why I was insisting. SQL is very very important. If you know SQL, then it's very easy for you. You will going to read data from the source. Okay, then you will create a view on top of the data. You mean some table like structure. Okay, so on top in that on top of the table like structure you can start performing your query. Select to start from table, select to start from all those things. Okay, you can apply those. That's why we call it as a Spark SQL. We can perform SQL things on top of this Spark with using the Spark functionalities. Okay, dictionary libraries, we use this to train our models, right? AI models and all we use to train that. Spark streaming, as we mentioned every on that day. So whenever an event happens, we need to process that event then and there. Then we need to send message to the user, hey, so and so money got debited from your account, right? Very, very fast. Then and the real time. That's what we call streaming. Streaming data means data keeps on coming. Okay, data keeps on coming. So that's the data you need to process and you need to generate the results. Okay, graphics means we mentioned right, LinkedIn, Facebook, Instagram. Like this is the place, social media we can consider. So this is where these connections will happen because you are a friend to many and your friend is friend to many, right? So like that. So there are some connections you need to make. That kind of processing also you can do with the help of Spark. Okay, this is Spark ecosystem. No, RDDs, right? Yesterday we decided what is RDD, right? Let's say whenever you wanted to perform any task. any process, any task, right? Work you need to do something, any job you wanted to. There are some certain steps. Step one, step two, step three, step four, step five. Okay, and we will consider each step as a stage. Okay, let's say we discussed about preparing a pizza, right? Pizza means first you need to go to the market and bring some maida, right? So that's step one, stage one. Okay, so that is done in parallel. Maybe you five guys will go to different places and bring that maida, or it's up to you. Parallel processing, parallel task. Okay, that's fine, but that is a stage one. That means without this maida you cannot start your next stage, right? Next step, right? Because this is a step one. Without maida you can never do that. That's why this should happen at least once, or in a parallel you guys will go to the different shops and bring each kg of maida for your own convenience. Okay, so that's one task, that's stage one. Okay, once that is done, every one of you will pour some water and mix some mixture, right? So that's step two. And this, without maida you cannot perform the step two. You have water but you do not have the maida, so you cannot do that. So with only these two ingredients, right, water and maida, you can only make the second mixture, that is stage two. Okay, so and you can never go back to stage one, because once it is mixed it can never be separated, right? You know, right? You guys will see in your households, right? So that's why it will never be step two. Now similarly the step three, you will make some a round shape, so some balls like structure, and you will do something. I forgot what we do for pizza, but yeah, if you do that, then that's it. You can never go to the backstage again. Maybe you go in real time, but in this park, right, you can never be able to go back. It's immutable. That's what we discussed, right? Once this is done, you are going to put it into oven. Fine, you will make the oven. Then once this is done, the final step will be step 5. You will going to bring it to your outlet, so that it will be reach the orders. Right, the person who ordered that pizza, right, it will reach that person. Right, the step by step process. Anything you do is a step by step process. If without step one, you can never perform step two. Okay, so that's why it should be done in sequential order. But maybe in the step one, you can do this parallel, right? So let's say you wanted to mix this. You want to make chapatis, right? So multiple people can make chapati at once, right? But that mixture, right, while you're mixing that mixture, right, then only one person can do, or multiple persons can also do. But let's think like only one person can do. Okay, without that mixture you cannot make your chapatis, right? Similarly, so in Spark, right, without the data set, right, reading, okay, first you need to read the data. Okay, wherever the data is, okay, you need to go and read the data. Fine, read the data. Now once you read that data, okay, you will divide that into partitions, right? That's what we discussed yesterday. Partitions, right? This is the data I read from the source means where your initial data lies. Target means where the data will end up. Okay, remember that, source and target. So from the source I will read this data. Okay, once I read this data, if it's hdfs has 128 MB of blocks. Okay, so now as a Spark, right, it will do some partitioning. What partitioning it will do is it will take this data set and do this into 128 MB of blocks. 128 MB of partitions, we can say, because in HFS we call them as a blocks. Here we call them as a partitions. Now if someone asks you how many partitions you will have in a Spark cluster, okay, for a 1 GB data, that was read from the HDFS, then you can say that it equal to, for 1 GB it's equal to 8 partitions, right? Or you can say that number of blocks in HDFS is equal to, double equal to, we can say, number of partitions in the Spark cluster. Okay, that's the initial number of partitions. Okay, so you will take those many partitions, and now this each partition will be given to each individual, each chef, each executor. Yesterday we discussed, right, the person who is doing that task is called an executor, right? So it will be passed to each executor, and each executor will start processing this data. Okay, this small amount of partition, right? That is step one. They will partition this data. Like again, think in this way: step one, step two, step three, step four. Step one, okay, stage one. We call it a step. From here onwards, we'll always call this step one as a stage one. Okay, so now stage one. This each executor will do the stage one. Now once stage one is completed in every executor, then you are going to start your stage two. Okay, once stage 2 is completed, then you are going to start your stage 3. Once stage 3 is completed, you are going to start your stage 4. But in between, if any one of the executor unable to perform the task that was given to him, right? Yesterday we discussed, if someone making the pizza, right? Then one of the pizza got fallen on the ground, right? He will not throw entire pizzas onto the ground, right? He will just ignore that one pizza, and he will again give ingredients. Ingredient means original data. So Spark driver program, right? He's the kitchen manager. He's the manager of his entire cluster, right? You will just keep track of which data you are processing. Let's say your data. Let's say I gave some this data. Okay, so this is the data. This partition zero. So partition zero is being processed by executor one. Okay, by any chance, this partition one got lost. Okay, the executor unable to perform, executor got failed, some issue happened. No, I'm unable to get output for this partition zero. Okay, then what I will do is, I know, right? I know that. Okay, here from here I done partitions, three partitions. And this till this 102 finance, 105 IT, 108 HR is the partition zero. And this got lost, somehow it got lost from that executor. Now what I will do, I will take this data again, and I will give you to the executor, to the another executor. Okay, and I will ask that to process it. Right? It will process that and it will give it to me. Okay, then that's what this RDDs will do, right? Resilient data set structure. So resilient means fault tolerance. Is capable of rebuilding data on failure, right? That's what we just saw. If one of the partition got lost, okay, by any reason, then we will we will just construct the data again, construct the data again. That's what we are saying, rebuilding data again on failure. Okay, and then we can start processing the data again. And distributed, right? Distributed in the sense, among, like, yeah, the single executor is not processing the entire data. um, Distributed data among the multiple nodes in the cluster. Okay, the data is distributed among the multiple nodes in the cluster. Okay, now coming to dataset. Dataset means collection of partition data, like all this data, right? So this is a, if you see in the top view, this is a single data. This is a single data. Okay, these are the partition zero, partition one, partition. This is a single data. This is what we call as a data set. Okay, so that's what this RAD means. And all of these are lazy evolution, right? We discuss the fundamental data structure for an Spark, right? The fundamental data structure is RDD, because that's what the fundamental rule that Spark follows. Okay, I will take data, I will do the partition, and if one of the partition got failed, I will again rebuild the data, and I will process the data again. Okay, and immutable. Once a RDC is created, it cannot be changed. Okay, it cannot be changed. And any transformation applied on a RDD creates a new RDD. Okay, leaving the original one untouched. So if you do some transformations, that's what we discussed, right? RDDs means, let's say you think in a real time example, if something you did to some this either photo or something, right, you cannot come back to that original position again, right? Original form again. So that's why you're going to create a new form of that RDD. So that's why whenever some transformation applied on top of RDD, you are going to create a new RDD. Okay, leaving the original one untouched. Immutable means cannot be changed. Once it was created, it cannot be changed unless, if you let's say you create something. Okay, it cannot be unchanged. That means it cannot go into previous stage, it cannot go into next stage. All we need to do is just apply transformation on top of that and create one more array. That's it. If you have two transformations, let's say RDD1, you uploaded transformation 1. Okay, then you are going to create RDD2. Fine. Now you are going to apply transformation on RDD2, you are going to create RDD3. Right, whatever transformations you do on RDD n, it's going to create RDD n plus 1. Okay, immutable. Resilience, we already see fault tolerant. If any one of the data set got, I mean partition got lost, it knows how to reconstruct that failed data, and it will give that data again to some other executor, and that executor will do the execution. Okay, lazy evolution. We already discussed, right? Without an order, if you are going to prepare 100 pieces, then that's a waste of money. Similarly, without an action, I told you right yesterday, transformations and actions are very keywords in Spark. So without an action, your Spark won't do anything. Until unless an action is called, Spark won't do anything. Until unless someone orders a pizza, you won't prepare a pizza. Okay, lazy evolution. Partitioning, we saw, right? Whenever you receive the data, so to make the parallel processing, because you do not want to process this entire data at one time, you wanted to make it into parallel. Parallel means you wanted to take this data and do small chunks, and each small chunk you will give it to one executor, and that executor will let's say 10 executors, you will take your data, you will do 10 partitions, so that 10 each executor will get one small chunk of data, and they will process that small chunk of data, right? That's what partitioning is all about. And in memory computation, means we discussed Spark will do the processing in memory, right? In RAM, right? In memory computation, distributed in nature, you already know REDs are can be processed parallel across a Spark structure, right? Because that's what makes the speed, right? If 10 members, see, if single member doing a task in 20 minutes, if 20 people doing the task, it will be done in 1 minute, right? That's what parallel will do, right? If one person is taking 20 minutes of time, right? In real time, you might have seen, if one person is doing the task, it might take so much amount of time, but if multiple people are doing the task, it will take very less amount of speed, right? Speed, persistence, right? If let's say in between, while you are working with your RDDs and all, right? So in between, if you wanted to save some data, okay, save some data, and that data you wanted to reuse again and again, okay, instead of constructing that data again and again, you are going to save the data, you are going to cache the data, you are going to persistence means uh, what we call in normal example cache, like you'll just save it somewhere, you will retain that result, okay, after that processing data. Let's say stage 1, stage 2, stage 3, stage 1, stage 2 is very important, so that instead of reconstructing, recomputing, okay, reprocessing the stage 2 again and again, once stage 2 is completed, you will save the data of that stage 2, okay. Now once you move to stage 3, stage 4, stage 5, in future any stage, it's fine, but whenever you want this stage 2, you can still use that. Okay, that's stage two. Now, operations. Two types of operation can be performed on top of RDDs, which we discussed yesterday. Transformations, which create a new RDD. Okay, and actions. Actions means you need to give action means you need to give your output to someone. Okay, think in this way, simple. Whenever an action is called, you need to give your output to someone. It could be driver program, it could be external storage system, it could be input to another stage, okay, another stage or something. Just you need to give some output to the people. Okay, how by data partitioning, data distribution, and customer partitioning. Okay, that's we will do. So when, like, in case if you have any doubts, okay, so let me put a simple example. Okay, in India there are 140 crores of people, right? Each one will have a Aadhaar card. Fine. That means you will have 140 crore Aadhaar cards. Fine, 140 crore Aadhaar cards. If I ask you to, you have all 140 crores of data in front of you in Excel file. Okay, not in Excel file, just let's think of some text file or something. Okay, now you wanted to search for some data, some person's details. Then how you are going to do? You're going to scan from, let's say that person record exists in 140 crore line. Okay, then if you wanted to search for that person, you need to pass through all this 140 crore data rows, right? So which is very inefficient. Now what I will do is I will take state of that person. Okay, let's say we have some example of, let's say 10 states. Okay, I will divide this state into 10 states. Now if I know, if I want, if again I'm going to search for that person, what I will do, I will go and do search for that person. But here, if I were able to get to the person I'm going to search, right? If I know that state of that person, it will be very easy, right? Instead of going and checking into all these 10 states, okay, 10 states, I will pick one state, because let's say he belongs to Maharashtra. Then I'm going to pick my Maharashtra partition. Then I will go there and I will start searching there. Okay, that's how you will reduce number of lines you're scanning, right? That's what partitioning will help you. But it's just small sample, but once you keep going, right, you will see many concepts: partitioning, bucketing, because every time you cannot do a partitioning, right? If you do partitioning, um, let's say if you do a partitioning, one of the partition has huge amount of data, but other partitions has very less amount of data, right, which is inefficient. So you will see this bucketing concept. Whenever you are unable to perform a partitioning, you're going to do bucketing. Okay, and inside this partitioning also you can create a bucketing as well. So just remember these types: partitioning and bucketing. We are going to discuss in future. Okay, this is how partition looks, and each partition will be going to each node. Node means executor, and that executor will process that partition. Perfect, right? Now we are going to start transformations. So for any doubts, any clarifications needed or anything, or are you clear? Yes or no? Hello?
No, no doubts, no doubts.
No
Cool.
doubt, sir.
Okay, fine. Just go through this document again, okay? So this is like Bhagavad Gita for you, okay? So you need to go through this again and again so that you will get used to these terminologies, these concepts. Okay, fine.
Okay.
Um,
Yes, sir.
Anyone
that,
tell me what is, yeah, Ravi, I have one question to these
yeah,
people.
sure,
Can
sure.
anyone tell me what is lazy evaluation in Spark? Hello, am I audible, Ravi?
Yeah, yeah, you're audible. You're audible.
Okay.
Guys, actually, you know that answer. Just speak up. Even it's wrong, that's okay, fine.
Yes,
Just
yes.
speak up.
Just tell, na. Whatever idea you have, just inform.
Yes.
Ma'am, can you please repeat the question, ma'am?
Can you tell me what is lazy evaluation in Spark?
Ma'am, it is not actually executed, ma'am, immediately.
Why?
That is only the lazy evaluation, ma'am.
So why it will not execute easily? Any purpose behind this?
Because of that RDD
Mhm.
or data frames or something.
Anyone else can give the answer?
Seems
Second
no one
option
is.
that you can provide, you can start.
Yeah, yeah. Seems no one is going through this document after the class. Yesterday we discussed, right? Are you going to prepare pizza without any order? You can unmute yourself.
No, we'll not.
Why? Why we won't do that? Guys, please unmute yourself. Uh, okay. Why we are not going to? What was the issue we face? If you prepare the pizzas without any order, what happens?
It's waste,
Waste of money, waste of effort.
waste.
Right?
Yes, yes.
Similarly, in Spark will follow lazy evolution. That means if you do not need the data, why to compute the data and waste your resources and time? Okay. So Spark will prepare the data if and only if any action is called. Right? That's what we discussed yesterday. Right? Action and transformations. Right? Action is very important. Without any action, Spark won't do anything. Spark is very lazy. Very lazy. Right? Spark action is kind of a order for the Spark job. Okay. So whenever any action is called, then only Spark will start preparing the data. Start will start processing the data. Okay, just remember this thing. So that's why after the class, right, if you go through this document, you would, because you're just hearing, right, you're not doing taking. I'm hope like you're not taking any running notes, right?
Yes, yes. You need to go through the recordings again and again, go through the documents again and again, and you also need to practice SQL and Python. Otherwise, it will be difficult for you people to go through these topics because you will not understand at the end because you will forget everything. Whatever we first taught you, you will forget.
Yes, exactly. You will forget the same. Yesterday, if you remember, we are discussing all these points one by one. Even now, also we just discussed this point, but still you're not
Yes.
getting used to these words. So
Yes.
just try to
That's why
practice.
I asked. Okay.
Yeah, like it's one of the very important question in interviews
Yes.
actually. So they should be aware of these things. So what is a lazy evaluation? What is in-memory computation? All these things they should be aware of this. That's why I just asked them to just go through this document again and again. But seems no one is going through that.
So
At
these
least,
documents are in LMS, no? These documents
yeah, they are
uploaded
in
on.
LMS. Yeah, I'll even share in the group as well. But I think they are facing some issues while downloading from LMS. I think. But I will try to put it into this group chat as well so that you can start. Yeah, this document is in LMS as well. Okay. If you forgot to upload in the WhatsApp group, right, just ping me. I'll update there.
Okay.
Okay. Yeah. Fine. Yeah. Let's start. Okay. So transformations and actions. So we just now discussed without any actions, Spark is very lazy. So if it do not see any action, it won't do anything. Okay. Action means Action means for now you can think of it's like a you need to give your data to some customer, okay, some person, some random person. Okay, just now for think of it in that way. Okay, action. You need to do that. Transformation means we discussed a pizza example, right? You take one form of ingredient, okay, you are converting into another form, right? So the process you are doing to convert from one form to another form is what transformation means. That's what transformation means, right? Transformation we had very often, right? Before 100 cases, after 80 cases, right? The transformation, right? Similarly, see here also the data transformation means what happens is before, let's say, let's go with some good example. Okay, so let's say one comma, Ravi comma, Teja, comma, Hyderabad. Okay, so this is my data before. Okay, so whenever you imagine data, right, you can imagine this like a column. First name, location. Okay, this is last name. Let me put in clearly. First name, last name, location. Okay, before data. Okay, now the transformations I'm going to do is okay. So now I wanted to combine the transformation here. What I wanted to do is combine. Okay, observe carefully. Combine both hmm, first name. I want to make it single line. First name and last name. Okay, this was the transformations I wanted to do. Okay, now I combine that name. Let's say full name. Now full name. Now this is what my name looks like. Okay, this is the transformations. Okay, this is the transformation. Like, see if you see here before the transformation, the data looks like this. Okay, after transformation, data looks like this. Okay, so here you done some coding here. Let's say you done some coding here. I will do some coding. For now, how this data will look like is, let's say data dot, okay, column, okay, for your information, like this is how the real coding looks like. Column of full name. I wanted to create a full name column, right? You see here, this is the full name column I wanted to create. Let me copy this. I'll copy this. Okay, go here, paste it here, full name. And what are the columns I'm just concatenating? Combining means in real world you can call as concat. Okay, this is concat. Okay, this is the first name. You'll take this first name. Okay, and last name. Okay, now this is what the this is what the transformations we are doing here. Okay, this is how your code looks like. Okay, this is what the transformations looks like before transformations and after transformations. And for your information, as Spark is lazy, by seeing this code, right, this code, it won't do anything. It won't do anything. because I will calculate this data. Let's think. Spark is not lazy evaluation. Spark is very active evaluation. Okay, so it will calculate this data. After calculating this data, what it will do? It needs to keep the data as it is in its own cluster, right? Because there is nowhere it needs to give the data. It shouldn't. It is not supposed to show the data unless someone asked it. That Spark cannot do that. So that's why Spark is lazy evaluation. That means it's waste of money, right? Waste of energy, right? Until an action is called, it won't show the data. What is the action? What is the action? Very simple action. Let me go through very simple action. Show you a very simple action. Data dot show. That's it. This is a simple action, small action. Okay. Now Spark needs to display this data to the user, right? See, if I do not call this data dot show, you will never see this output. Okay. After transformation, this is the output. Okay, so if I do not call this data dot show, this is a small action, right? It's very easy to understand, right? Show means show me the data, show me the data, show me the data. Okay, simple. Now this is what we take from before transformation data looks like this, and we done some transformations on top of that, and then we are able to see the data. We are able to perform small action on top of that data, right? Then you are able to see this output, right? This is a small action. This is where this lazy evolution comes in. Without this small action, okay, without this small action, Spark won't do anything. Okay, if this action is not there, if this is not there, you will never see this data because there is no action. Spark won't do the calculating. Spark won't do the transformation. Okay, that's why you need this small action. Then only Spark will perform the transformation. Okay, without any action is called, Spark won't perform any transformation. Okay, so that's what lazy evaluation means. Similarly, this is what the transformations. Okay, transformation is Spark. In Spark, a transformation is the operation applied on RDD. Okay, RDD, that small line, right? I took that is an RDD. Okay, or data frame or data set to create a new RDD or data frame or data set, right? Because if you see here, this is RDD1. We just discussed, right? RDD1. Okay, and we just now discussed, right? RDD1 plus transformation, okay, equal to what? What it will do? If I apply any transformation in an RDD, is it going to create new RDD or it will stay in the same RDD? Can anyone let me know? Any transformations applied on top of RDD1, is it going to create a new RDD or not? Yes, right? RDD1 plus transformations will give you RDD2, right? So this is RDD1 for you, small RDD1, okay, and this is RDD2 for you, right? Not this actually, the below data. This is the transformation. This is where transformation happens, right? This is where the transformation happens. This is RDD1, okay. This is RDD1. This is RDD2. This is RDD2. So RDD1, any transformation that we created on RDD1 created an RDD2. New RDD, right? It's not equal to this, right? It's not equal to this. It's a new RDD, right? That's how this happens in the real time. Okay. So then that's what he is saying. A transformation is an operation. It's an operation, right? The transformation is an operation applied on an RDD or data frame or data set to create a new RDD. That's it. Very simple, right? Very simple. Now, transformation in Spark are categorized into two types. Two types. There are two types of transformations. Okay, narrow transformation and wider transformation. Just remember these names: narrow transformation, wider transformations. I'll show you what is narrow transformations and wider transformations. Okay. How many types of transformations in Spark? Just please be active. Okay. So these are the classes which you are going to get many insights. Okay. Just please be active. Okay. Narrow transformations and wider transformations. Actually, I wanted to create a data set for you. Okay. Mm, Let me go with a line. Go with a simple line. Um, let me take some random line from this. Any random line and this. Any random line. Okay. Let me take this small line. Okay. I want to count. I want to count number of votes. This is a data set to me. Okay. Data set to me. Okay. I want to count the task or the result I want to see is number of votes in the below data set or data frame. You can remember data frame. You're going to hear this data frame term very often. Okay, data frame. Okay, or data. Okay, whatever at your convenience, you can remember this. Okay, data set, data frame, or data. Okay. Now what I need to do? What I need to do? So this is my data set. What is the first step I'm going to do? Just you can unmute yourself. Okay. What is the first step I need to do? The moment I read the data, what is the first thing I need to do? We discuss some concepts, right? What is the first thing we are going to do? You can unmute yourself so that you can involve actively. Hello. Even it's incorrect, no problem. You can just speak up. What is the first step we will do? Like you can think in real time as well. So what is the first thing we will do? We'll go to market and bring ingredients, right? To make 100 pieces. Now first, what was the first thing you will do? I do not want technical as well. Just what is the first thing you will do? 100 pieces. Are you going to do that 100 pieces alone, or are you going to divide the task? Um,
Divide the task, sir.
Divide the task. Okay. How do you task? How do you divide the task? Divide the task. Okay. So you identified 5 people. These 5 people we refer as what? I mentioned some name, right? These 5 people who are performing the task, we call them as executors. Okay. So the persons who are going to execute the task are called person or node or device. Okay. Execute the task are called as executors. Okay. Now someone needs to make this right 100 pieces. Now you identify 5 people. Okay, 5 people. Fine. Ingredients is equal to data. Okay. People is equal to executors. Okay. Fine. Now I'm just making the list of okay number of tasks is equal to task 100 by I have 5 executors, right? 5 executors, 5 is equal to 20 pizzas each for the executor. You understand this calculation first? How I did? In this example, in this pizza example, this ingredients is equal to data. Okay, so I will refer this ingredients as a data. Okay, and people, right? People I will refer as executors. Okay, I'll refer as executors. Fine. Now, how will I decide number of tasks for each person? Okay, based on the number of pizzas I need to make by number of people I have. Okay, now I get 20 pizzas each for the executor I mean each for the people, for the person. Okay. Now, now I'll take this. Okay. What is the first step I will do? Just tell me normal words. I told you right. I will never going to call this as step. I'm going to call this as a stage. Okay. Stage. What is the first stage? What is the first step I'm going to do? You can think. You can think. So are you going to divide these ingredients among yourself so that you can start preparing that the first initial stage, first initial step, right? You know the instructions as well. Okay, so how to make that pizza? You're going to start that first. Take the data, divide that. Like, what was the first thing you're going to do? See, you guys are speaking and I'm unable to hear it. I'm not sure. But if you're speaking and I'm unable to hear, just post in the chat. You will get to know. Someone pinged. So that means you're speaking and we are unable to hear you. I'm unable to hear you, right? Hello. Um, can you please unmute yourself? Yeah, Karthik, yeah.
Yes, sir.
Okay, you are able to speak. Fine. At least I'm good. You're able to speak. Okay. So what are the first steps we are going to do here? First step we are going to do here. See, think in normal terms. Normal terms. I do not want any technical answer. Just give me the normal answer. Just speak something. Then we will work together to get that answer. What is the first thing we will do here? Anisha, what is the first thing we will do here? What will you do?
Um,
Hmm.
Data represents,
Data
um,
represents.
yeah, represents
Okay,
the
represent.
data represents the data sets. I don't know properly, sir. I'm just saying it.
Okay, no problem, no problem. Just if you start speaking something, I will walk you through. I will walk you through. Okay. So the moment you need to work together with five people. Okay, and five
Hmm.
people are equal here. What is the first thing you are going to do here? You have this data, right? These ingredients, right? What will you
Yeah.
do with these ingredients? Each one needs to prepare 20 pizzas. Then what was the first thing you are going to do?
Count the pizzas.
Yeah, sorry, Karthik.
So collect that.
Hmm.
First, we collect the data.
Collect the data.
Collect the data. Fine, perfect. I just collect the data. Fine. Step one. Collect the data. This is the data, right?
Then,
Collect the ingredients. Okay. That means collect the
then
data.
you spoke about people.
People. Okay.
That is executor.
Executor. Okay.
It will process,
Hmm.
like execute the task.
Executors will execute the task. Perfect. But this data, right? We are not going to do process the data as it is. We are going to do some steps here before processing this data. We discuss some parallel. So just simple. Whenever someone asks anything, that you can always refer to your MapReduce. What we will do in MapReduce once you have the data. What was the first thing you will do in the MapReduce?
Transformation.
No transformations. So before doing transformations, so
Split
if
the
you
data,
remember,
sir.
who said that? Arun, right?
Yes, sir.
Perfect, Arun. So split the data. Okay. That's what we discussed, right? Split the data. First thing, split the data. So you have five executors. They needs to perform some task. Okay. Let's think in this way. Okay. These five people are in five different rooms. Okay. They need to start working with this data. Then how they are going to do that? Right? They need some data, right? At least then only they can start preparing pizzas, right? So that's why you need to split the data. That means here we will call them as partition the data. Okay. Fine. You have the partitions. How many partitions we will have it here? How many partitions? How many
5.
five?
Five.
Why? Why five?
Five.
Why five
Five.
partitions?
We take 5
Exit.
Each
members.
getting 20 people.
Yeah, each getting 20, and you have only five executors to
5,
execute
yes.
that. Right? Five executors. Perfect. Okay, executors. Fine. You will have five partitions because you have five executors. Five executors. Perfect. Okay. Now what is the next text? You can think of map reduce as well, no problem. I'm okay with that. Just tell me what we will do next. You have five partitions, so that means I will take this data. This is the data to me. Okay. I'm not going with visa, I'm going with this example for now. Just for example. Five partitions. That means this is partition one. Okay. This is partition two. That's how we partition, right? If you remember, we discussed yesterday on that class, right? You can never partition this transformation data like this, right? You need to partition on the board wise, right? That's why we mentioned the input split type. If you remember, we discussed this in map reduce class. Okay. Now, okay. Now this is the third line, fifth partition. Okay. So this is the partition one. For now, I will go with P1, P2, P3 partitions. Okay. What is the next thing I'm going to do here? In the map reduce, you can just think in blocks or input splits, right? We just discussed in the map reduce. Okay. What is the next thing I will do?
Mapping.
Mapping. Exactly. Who said this? I'm not sure, but mapping.
Got
Mapping. Yeah, got it. Mapping. That means you will map this each partition to each executor, right? Mapping. P1 is mapped to executor 1. E1 means executor 1. Okay. P2, you're going to map to E2. P3, you're going to map to uh, E4. E3. Okay. Maybe you'll get confused, but it won't work in like this in the real time. Okay. E4. P5 is mapped to E5. Perfect. Now what will happen? Now what will happen? On mapping is done. Okay. Now what happens here? Hmm?
Split the
Shuffle.
data.
Sorry.
Shuffle and sort.
Suppose
Shuffle
next
and
to
sort. Okay. Before that,
split the data. And
split the data. Okay. You already split that partition, right? You need to
yes,
do number of words in this data. So how we are
uh,
going to? What is the first thing you are
Reducing,
going?
sir.
okay.
Reducing? No.
Transfer the
Transformations. Okay. Transformations. You can call this as transformations. Okay. What is the transformations you need to do? We already
transfer the
discussed
input data.
input data. Okay. How you are going to do this is, you remember,
We take
I
key
just
values.
key values. Exactly. Key values. K comma 1. This is one key value. Okay. This is one more key value, right? Right. This is how we calculated on that day. Right. N comma 1. Right. This is what we did on that day. Transformation. Right. Somehow, some logic I written in my job. Okay. So then this is what the key value page looks like. Now, this is what keys and their values. Fine. Now, similar things will happen with the other processings as well, right? Other transformations as well, right? Because here, how many transformations I will have? In fact, let me know. This is
Five.
transformation one. Five transformations. Okay. But, but but here you have only one transformations in the high level. Okay, in the real world, right, you will never think how many executors you have is equal to number of transformations. No, executors never equal to transformations. You have only one transformations. That transformation is you need to make number of ports. You need to count number of ports here. Okay, you need to count number of ports here. That's it. That's the only transformation you need to do. See, this is the entire data set. Okay, I need to take this data and similarly, where is this previous? Okay, if you saw here, this is the one data set, right? I just take this data, did these transformations. This is the transformation. I did that combination. Okay, and I just created this. So this transformation is the recipe. Okay, I'm again insisting it's recipe. Recipe, can the recipe be given to everyone who are making the pizza? Can that be given? Right? It can be given, right?
Yes.
Like without knowing recipe, can you make a pizza? Yes or no?
No.
No. So that means everyone needs to know the recipe, right? Everyone needs to know the recipe, as well as everyone needs to have the data. Similarly, here every executor, okay, every executor needs to know the recipe. Here, what is recipe? The code or transformation. Okay. Now tell me how many recipes you will have here.
One.
One. Okay. One recipe will be given to every executor. That means one transformation logic, let's say logic, will be given to every executor. Okay. Every executor will get this, needs to know the recipe code for the transformation logic. Okay. Perfect. Till here you understand, right? Any doubts? First thing
Not.
is,
No.
whenever you wanted to prepare any you wanted to perform any step, right? First thing is you need to collect the data. First step one. So sorry, stage one. If I call it as a stage one, step one, then it's a incorrect word. Okay, stage one. Then stage two, you're going to split the data. Okay, stage two. Now in stage three, you're going to map. Okay, but technically it bit differs. But okay, for now you can just go with for your better understanding. Okay, now I'm just mapping data to the data mapping. Data mapping to the executor. Okay, now stage four. Okay, stage more is a recipe mapping. Okay, perfect. Recipe mapping. Right, now you are aware of this stage 4 as well. Now stage 5, this executors, right, executors need to need to execute this code given to them. Code or recipe you can call. Okay, recipe to I given to them. Right, this is what they need to do. Right, they need to do. Okay, now stage 6. Once it is done, executors executed the recipe. It needs to give it needs to give. Once you prepare the data, what prepare the pizza, what we will do?
Top the
You give it to the, let's say, outlet. You can get outlet, right?
yes,
From there, the person who wanted to take, they will come and collect. This outlet is driver for us. Okay, driver. So once you prepare the data, you need to give in. It needs to give the output, the pizzas, nothing but output, right? That's what the output. It needs to give the pizzas or output to outlet or driver program. Okay. Now stage 6, 7, sorry. Now driver will take care or outlet will take care who will access the data. Okay. So now so far clear. Any doubts here?
No.
No? Cool. Okay. So what did you understand here? So just tell me the process involved here. What are the stage one, stage two, stage three? Okay. You can collect. You can think in a data perspective. So first, what was the first thing you need to do?
Collect the data.
Collect the data. Perfect. Next thing,
Then we are going to split the data
split the data.
in,
Okay.
um, and then we are going to transform
Transform.
um,
Okay. You can do the transform. Transform means a recipe in our case, right? That's what we discussed, recipe or the code we can say. Okay. That is a code. But without a data, can you do any transformation?
no,
No. Then what was the first thing we need to give it to the executor? Data or code? Anything is fine, but you need to give both, right? At least
yeah,
maybe it's one by one or first transformation and then code and first code and then transformation something. But we need to give both to the executors, right? Then only they can execute the data, right?
yeah, yeah.
Okay.
The
Then
transform
recipe mapping and data mapping you can to that executor. Okay. Then once this is done, what the executors will do? Once they get both
transform
the data and they will perform the transformation. Okay. They will do the code. They will
transform.
execute the
Yeah.
code. Right? In fact,
Yes.
they will execute the code. Okay. And stage six. Once the code is executed, then what they will do?
Um, Giving it to the outlet
Giving it to the
or
outlet. Who is the outlet here?
driver.
Driver. Perfect. Then what driver will do?
Um, Driver will take it to
Hmm.
whoever access the data.
Who needs that access? Perfect. Okay, fine. Um, but in real time, right? So these are the steps involved in the real time. But we discussed one more thing, lazy evolution, right? What is a lazy evolution? What is a lazy evolution? Just let me know. What is lazy evolution? You just saw that, right? Few minutes before. What is lazy evolution? Um,
Does not execute immediately.
exactly. Does not execute immediately. When will it execute it?
Mm. When
If
there
some
are any actions.
actions, perfect. So that doesn't mean that means that here the transformations won't happen unless you have a unless you have a it won't execute the transformations unless there is an dash. What is that? No transformation until dash is called. What is this? What is this? Empty. We just discussed, right? It's action, right? No transformation is executed until an action is called. Right? That's what we discussed. Right? Until an action is called, no transformation, no transformation is called. Right? No transformation is executed until an action is called. Similarly, if no one see whenever you think of a lazy evolution, that thinks in pizza way. If no one is ordering the pizza, why won't you prepare the pizza? Right? Think in that way, that perspective. Lazy evolution. If and only if there is an order, then only you will prepare the pizza. Okay, simple as that. I know it's very beginner, right? You guys are beginner and you don't have any knowledge on the data set, right? We are directly starting working on this Spark thing, right? It will be difficult for you, but that's okay. But after this class, right? After this class, if you start going through the recording again, if you start seeing the class notes and all this stuff, right? You'll get to know things. You'll understand things better. Okay. If not, you will never get you will never understand these things. Okay. When you guys facing any network issues? Because I see multiple people getting disconnected and connecting back. Network issues or any platform issues you're facing?
Sir, actually the network goes all of a sudden immediately and it connects back.
Everyone is facing same issue.
I'm facing sometimes, not every day, sometimes I'm facing.
Okay. Arun, what about you? I see you connecting, disconnecting multiple times and connecting back. Hello, Arun, are you there? That's okay, but if you have any issues related to this platform, right, just don't be silent. Just please speak up so that someone will help you out. Subhashri or someone, someone will take it to the higher people and they will get it resolved. Okay, just speak up because these are the very important classes. We are going in very slow pace actually. So it seems Arun left again. That means he is
He
facing some.
can't hear anything he said.
He can't hear anything. Okay, fine. Okay, I think there is some serious platform issues. Subhashri, if you could take these things, that will be helpful because people are disconnecting multiple times and connecting back. So in between, right, they will miss those classes or something, right? Some concept, right? There should be continuity. So seems they are missing these things. So that's it. Please take care of this. Yeah, that's it for today's class. I know I took extra 15 minutes, 10 minutes of your time. Okay, so but these things needs that time. Okay, no problem. But tomorrow we were going to discuss on wider transformation and narrow transformations similarly. But when you are coming to tomorrow's class, right, please go through these concepts again, please. Okay, because without that knowledge, if you come to the class, everything is like new class to you. You won't understand anything. Okay, please try to. If you are okay, just go and research and Google what is wider transformation, what is narrow transformation. That's it. You can go and ask the AI models as well. Just spend some 15 minutes. 15 minutes. That's it. Just go through revise today's class plus 15 minutes for what is the tomorrow's class. You know the PPTs, right? We have the PPTs here. Just you can go through what are the next things I'm going to discuss in this class. That's it. Small things. Just 15 minutes every day because this is your career, right? You are here for to brighten your career, right? So these are the small things. Just half an hour. Spend half an hour in a day. That's it. Just for these Spark classes. Okay. Python and SQL, it's up to you. If you're going to prepare, you're going to become a good data engineer. If you're not preparing, then that's it. It's up to you. Okay. You need to do the action. Okay. We cannot force you to do the action. Okay. That's it. Subhash, do you have anything? Because today's class, if you guys have any doubts, you can just let me know. If not, you can wind up. Yeah.
No, sir, we'll go through the recording again.
Yeah, you can go to the recording, or if you wanted to have want to go to Google and search it, absolutely fine. Just go and search for that concepts. That's it. What is wider transformation? What is narrow transformation? If you come to the class prepared, right, it will be very easy for you as well. Okay. And if I say something, it was the first time that you're heading that listening to that concept, right, then it be difficult for you to it be difficult for your brain to process, right, those new keywords, right? So that's why always try to do that. Yesterday I discussed DAG, right? Direct acyclic graph. We discussed. I showed you some example, right? So what is the DAG? You can just go to Google and search that. Right? What is DAG? What is driver program? Right? All these things you can just go. What is action? See, if you see, these are the RDDs. These are parallel, right? Parallel partitions we created. Create an RDD. Transformations. It will create a new RDD. Okay, an action. The result, right? These are small concepts, right? Read operation, write operation, all these things. You can just go to the lazy evolution, right? Executed doesn't start until an action is triggered, right? That's what we are discussing from the class one. You will never prepare a pizza until you have an order for a pizza. That's what we discussed. Simple example. Similarly, just remember those examples and try to put it in technical words. Execution doesn't start until an action is start, right? That's it. Lineage, graph, or tag, right? These are these are very easy concepts actually, but I'm still taking so much of time so that every one of you to understand. Okay, lineage, right? Step by step, right? All the steps we discussed, right? I discussed about step 5 steps here, right? 5 steps means that means, see, I discussed 7 steps here. That means lineage, right? If step 4 got failed, Am I going to start from the step one? No, right? I'm going to start from the stage three itself, right? That's what cleanness means. You're taking that cleanness. You're taking that cleanness. You're utilizing the cleanness to just start from the stage, okay? And stage concept, you already know job and task, right? You can. It's very easy for you because you already put those examples, those kind of examples. So once you start hearing these steps, right, it will be very easy for you, right? Stage you already know. That means without preparing your stage 3 you're never going to go into stage 4, right? That's what we discussed. That's what stage actually means here. If you read this, it will be very easy for you without shuffling. Okay, without shuffling, just remember this cue, without shuffling data around. Okay, how DAG looks like. These things you will get to see once we start practicing. Okay, job 1, job 0, stages, all these things. Okay, just try to go through this document. Okay, even though the concepts we are not going to cover right tomorrow. Okay, just go through this concepts. Okay, it will be helpful for you. Okay, that's it. Uh,
Sir, could you send a PDF to WhatsApp group, sir?
yeah, I'll send it. I'll send it. Yeah, I'll send it next 30 minutes. If I do not send it, just please ping me in the WhatsApp. Okay.
Okay, sir.
Okay.
Okay. Thank you. Thank you all.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you.